Hello class, welcome to our second lesson dealing with section 5.2. We're going to continue to look at the random variable idea and along with the probability distributions. First thing that I want to talk about is just unusual results when it comes to probability and with the distribution table. Remember back when we did statistics earlier, we said everything within 2 standard deviations would be considered usual. Anything outside of 2 standard deviations would be considered unusual. That same idea applies to percentages with probabilities. The idea is if it's 2 standard deviations, that's where 95% of the data is. That leaves 5% to be unusual. And so when we look at probability, if you add up probabilities from wherever you're at to the end, so an unusually high number would be whatever the probability of what you have plus all the rest of them is less than 5%, or what you have and everything less than you is 5%. It'll make more sense in the table format. The reason it can't be just that number itself is because once you get a bigger sample size and a bigger set of data that you're looking at, all the probabilities themselves would be unusual, but collectively they're probably not unusual. So that'll make a little bit more sense, I think, with our example. So would getting 0 of the 5 tosses being tails be unusual? This is the same table that we dealt with in the previous class where it was an unfair coin, 70% probability, or 0.70 probability of getting tails. So would getting 0 tails be unusual? Now in this case, you could get away with doing the wrong thing. Getting 0 tails is only this number right here, 0.002. And you ask yourself, is that less than 5%? And the answer is yes. So that would be very unusual to get 0 tosses out of 5 to be tails. The next one says would getting 1 tail out of the 5 tosses be unusual? But in this case, you can't just go to 1 and say, yes, that's less than 5%. You have to take that and everything below it, okay, or everything, in this case, above in the table, but that represents lower numbers. So I need to add how probability you get 1 tail and the probability you get 0 tails. Add those both together, and it's still less than 5%. Let's say it was 3 or above. Okay, if it was 3, a probability of 3, I'd take 3, 4, and 5 and add those together. Now that one would be not unusual because it's higher than 5%, whereas this first one, okay, these two add together to be less than 5% as you're looking at it. So anytime you're asked to see if something's unusual, you have to take that all the way to the end, whether it be below or above, depending on which one's closer. The next topic to talk about is what's known as expected value. Expected value is just a fancy way to say the mean. It's what we should expect to happen if we continue the experiment or continue the trials for an indefinite amount of time. It's important to remember that expected values typically are not whole numbers. Okay, this would be the idea if you follow any type of sporting event, like points per game is typically not a whole number, so you could average 10.7 points even though you can't get 10.7 points. The same would be true on an average for a test. My class average could be 81.7, where it's actually impossible to get 81.7 on a test. So expected values is the mean, and so we can just use that terminology in the same way to find our answers. This question deals with a green pea pod. So this says the probability of getting a green pea pod is 0.75 or 75%. We're trying to say the number of peas with green pods, and we're looking at 5 different peas to look at. So this first one is number of peas is 0 that are green, and this is the probability that would occur, which makes sense because it's 75% chance that we get a green one. 1 of the 5, this is the probability. 2 of the 5, this is the probability. 3 of the 5, etc., all the way down to 5. Now to find the probability, to find the mean, remember it's x times p of x, so I would take 0 times 0.001 plus 1 times 0.015 plus 2 times 0.088, etc., and go down the list and multiply all of them together and add them up as I go, and I should get 3.75. That's the expected value as well. So what I should expect to happen is every time I have 5 p's, I should expect that 3.75 of them will be green. So if I got 3 or 4, I'd say, oh yeah, that makes sense, because I should get 3.75. You have to know how to do the mean by hand, but the standard deviation and variance, you can use stat calculator custom and use L1, L2. Make sure that you've tested that out to try it out, because you shouldn't be doing the standard deviation and variance by hand. A lot of the homework questions will probably say some things like that, but you don't need to do those pieces by hand as you're trying to find those solutions. Use StatCrunch to be able to find that, or I'll give you enough info that you will have what you need in order to find the answer. Okay, the next question is a pick 4 lottery game. So remember, pick 4 is there's a number, another number 4 times, and it's 10 times 10 times 10 times 10. So the number of selections is just 10 to the 4th because the numbers can repeat themselves. If they said they couldn't repeat themselves, then it'd be 10 times 9 times 8 times 7. So there's 10,000 ways to play the game. The probability you win the game is 1 out of 10,000. Now, I base those two answers just on the fact that it's a pick 4 lottery game. I don't care how much I paid. I don't care how much I win. All I'm caring about is how many options, what's the probability I win, and then I can use that to help move forward. If I win, my net profit is how much I collect minus how much I put into the game. So it's the $27.88 minus the 50 cents I put in, and I end up with a profit of $27.87 and 50 cents. Okay, just under the amount because I have to get my 50 cents back, and then the rest is my profit. The whole point of the setup of those 3 pieces is to find the expected value. So the expected value, essentially what you want to do is the x p of x. So x would be winning and losing, for example, how much money you put in and what's the probability that it occurs. How much money do you lose? What's the probability it occurs? So the expected value here would be I lose 50 cents, so that's negative 0.50 because I'm losing it, and I should expect that to happen 9,999 times out of 10,000, all the ways but one. So negative 0.5 times everything but the one way to win, that's the x times p of x for losing. Plus the profit for winning would be what we just found here on the left side. You got to make sure you get rid of the 50 cents. Okay, so I take that 2,787 and 50 cents times 1 out of 10,000. What should happen here is I get a negative expected value. If you get a positive expected value, I doubt that's the case because in any game that's like this, you should expect to lose. So I should get negative 0.2212, which is about negative 22 cents. Now, if I were to play the game, I should probably just expect to lose my 50 cents. But since someone's going to win, the expected value to the company is they should expect to lose 22 cents. Every customer, when they buy something, should expect to lose that. This says the Illinois Pick 4 game has an expected value of negative 25 cents. Which one is a better bet for you to play? Now, realize probably both of them, the answer is don't play because you're going to lose. Okay, so in this situation, no matter what you do, you're probably going to end up losing. But if you were going to pick which one to play to have a better chance of winning, then the Illinois one is better because it has a higher expected value because these are both negatives and it's closer to 0. This last slide is important to make sure you understand. Okay, you don't need a StatCrunch to find that. You just plug into your calculator, show your setup. You're going to have to be able to do that on a test situation as well. So you want to make sure that you know how to find the expected value. You want to make sure you know how to compare expected values and deal with the profits of a game like this. Have a good day, everyone.